What's happening inside Jupiter? If our galaxy was a country, our solar system would be an amazing attraction point for tourism. Starting from the outside of it, a visitor could enjoy the presence of Neptune and Uranus, two blue-shaded planets so similar but at the same time so different from each other. One could, for example, organize a quick trip to Triton, the biggest Neptune satellite, and learn that this moon was probably captured by the planet itself in the past. One could study the solar system's history. Then, if one came closer towards the sun, he could see Saturn, a real art masterpiece. I mean, look at it. Its beautiful rings are literally out of this world, with its unique shape. I'm pretty sure it would be the Mona Lisa of our solar system. One could organize a trip towards Saturn in order to appreciate countless small and big particles that make up its rings, and he would realize that they are made almost entirely of water and ice, with a trace component of rocky material. Then one could visit Mars and say hi to rovers walking on its reddish surface, and finally, he would reach the Earth. This would be one of the most romantic stops for sure. He could see the moon and he could taste some ice cream while listening to Queen. And last but not least, our guests could visit Venus and Mercury. However, if our solar system was a city, the most known attraction would be Jupiter. It is enormous. It is monumental. If our solar system was Paris, Jupiter would probably be its Eiffel Tower. Or if it was Rome, Jupiter would be our Colosseum. What are you waiting for? Let's book some tickets. I'll be your guide for today, and I'll show you the secrets of the gaseous giant. In particular, what's inside of Jupiter. Keep watching to get to know more about it. In ancient Roman culture, Jupiter was the god of the sky and thunder. King of all gods, it has a special place in the Roman religion and mythology. Romans were regarding Jupiter as the equivalent of the Greek Zeus. In fact, in Latin literature and Roman art, the myths of Zeus are adapted under the name of Jupiter. Jupiter was Neptune's brother, the Roman equivalent for Poseidon, the god of the sea. Ancient Romans knew a lot of things about astronomy, but they didn't have telescopes yet, so they studied the things they could. They used their naked eye as an instrument to understand the cosmos. They knew that some of the biggest spots in the sky had pretty unique features. They were 5 and seemed pretty different from the stars. They called them Saturn, Mars, Venus, Mercury, and Jupiter. These planets were given their names thousands of years ago. The other planets in our solar system were not discovered until much later when telescopes were finally invented. But even then, the tradition of naming the planets after Roman gods and goddesses continued. Even nowadays, if you go out and take a look at the night sky, you can notice there are some bright spots that, unlike stars, don't twinkle. This is a pretty good way to recognize a planet in the sky. In these conditions, given a planet, you can track its trajectory in the sky, and with some effort you can tell how many days it takes in order to complete an orbit around the sun, namely its orbital period. But besides that, you can't really tell how beautiful and mysterious a planet is. You can't see features on its surface, and you cannot tell if there are some moon-like satellites orbiting around it. You can just treat it as a point in the sky because your naked eye is limited. That's why you need to develop some instruments, and that's exactly what humanity did, starting from 1600. The history of the telescope can be traced before the invention of the earliest known telescope, which appeared in 1608 in the Netherlands when a patent was submitted by Hans Lippershey, an eyeglass maker. Although Lippershey did not receive his patent, news of the invention soon spread across Europe. The design of these early refracting telescopes consisted of a convex objective lens and a concave eyepiece. Galileo improved on this design the following year and applied it to astronomy. In 1611, Johannes Kepler described how a far more useful telescope could be made with a convex objective lens and a convex eyepiece lens. With the help of such instruments, we were finally able to reveal new features of planets and to see further. The telescope is an artificial extension of our eyes. With its help, today we know that Jupiter looks like this, and that it has some moons orbiting around it. The most famous ones are Io, Europa, Ganymede, and Callisto, in order of distance from the gaseous planet. Thanks to new technologies and theories, today we know that Jupiter is the grandest planet in our solar system. 11 Earths could fit across Jupiter's equator. If Earth were the size of a grape, Jupiter would be the size of a basketball. We also know that it is the fifth planet from our star. It orbits about 484 million miles, or 778 million kilometers, or 5.2 astronomical units from our Sun. For definition, Earth lies at 1 AU from the Sun. We also know from kinematic studies that Jupiter has short days and long years. In fact, it rotates once about every 10 hours, which we call Jovian Day, but it takes about 12 Earth years to complete one orbit of the Sun. The days are much shorter on Jupiter, but the age on your ID card would be much less. If you are 36, congrats, you're 3 Jovian years old. Another important thing that we know about Jupiter is that, despite the fact that it is a massive world, its elements are light. Its atmosphere is made up mostly of hydrogen and helium. Is this all that we know? Of course not. We know Jupiter likes moons, and it owns more than 75 of them. We also know that it is a ringed world just as Saturn. All 4 giant planets in our solar system do have ring systems. Unlike Saturn, you just have to look closer and at higher resolutions in order to see them. The number of spacecraft that have visited Jupiter during the years is 9. 7 of them flew by and 2 of them have orbited the gas giant. The most recent one, Juno, arrived at Jupiter in 2016 and it is still at work. Among other things, we know that Jupiter has a unique red spot on it. It is called the Great Red Spot, and today we know it is a gigantic storm that's about twice the size of Earth and has raged for over a century. The Great Red Spot may have existed since before 1665, but it could also be the case that the present spot was first seen only in 1830 and well studied only after a prominent apparition in 1879. The storm that was seen in the 17th century may have been different from the storm that exists today. A long gap separates its period of current study after 1830 from its 17th century discovery. Whether the original spot dissipated and reformed, whether it faded, or if the observational record was simply poor is unknown. For example, the first sighting of the Great Red Spot is often credited to Robert Hooke, who described a spot on the planet in May 1664. However, it is likely that Hooke's spot was in another belt altogether. Much more convincing is Giovanni Cassini's description of a permanent spot the following year. With fluctuations in invisibility, Cassini's spot was observed from 1665 to 1713, but the 118-year observational gap makes the identity of the two spots inconclusive. The older spot's shorter observational history and slower motion than the modern spot make it difficult to conclude that they are the same. Okay, but what about the things we don't know? Is there something we're missing about Jupiter? Before finding out the answer to the question, be sure to like or dislike the video so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel, clicking the bell so that you don't miss any of our weekly videos. The answer is yes, we are missing something. For example, we don't know very well what's going on inside Jupiter. Jupiter is characterized by a frosty cold, but the temperature near the center heats up to over 43,000 degrees Fahrenheit. But how do these drastic temperature differences actually arise? As we've said before, this enormous gas giant is composed almost exclusively of helium and hydrogen. Normally, these chemical elements exist in a gaseous state of aggregation, but it actually depends on temperature and pressure. Sometimes hydrogen can be exposed to high temperatures and pressures. In that case, it liquefies. Have you ever been scuba diving? If you have experienced firsthand how the pressure differences play out in reality. The deeper you dive into the sea, the more water masses there are above you. This pressure weighs on you, and it's the same for hydrogen particles in the atmosphere of a planet when the pressure rises. At low pressure, the molecule possesses sufficient space to distribute themselves all over the layers. But when the pressure is really high, they don't have space and start to slowly squeeze and combine together. They lose their gaseous state and become liquid. The pressure level in the center of Jupiter reaches an enormous value of about 100,000 bar. At Jupiter's core, you would feel as much as 650 million pounds of pressure pressing down on every square inch of your body. That would be like having approximately 160,000 cars stacked up in every direction all over your body. Jupiter is a remarkably different world from our own. With all that gravity, normally lightweight hydrogen behaves in completely exotic ways. How does it translate in terms of the core? Is the core a solid one or liquid one? Experts believe these extreme conditions led to the formation of a solid planetary core, but this is still a matter of debate because an alternative hypothesis is that the center of the gas giant isn't a solid structure. In fact, according to some scientists, the core is a liquefied accumulation of boiling hot material. However, if it has a solid inner core at all, it's likely only about the size of Earth. So in short terms, we think we have two options. The first one is that the core of Jupiter is a solid one. The second hypothesis is that Jupiter has a boiling hot soup inside of it. NASA's Juno mission is designed to find answers to such remaining questions about Jupiter. The spacecraft is orbiting the giant planet, swooping in for close-up looks to get more detailed information. It successfully entered the orbit of Jupiter on July 4, 2016, and for the first time will peer below the dense cover of clouds to answer questions about the gas giant and the origins of our solar system. Juno's primary goal is also to reveal the story of Jupiter's formation and evolution. Using long-proven technologies on a spinning spacecraft placed in an elliptical polar orbit, Juno will observe Jupiter's gravity and magnetic fields, atmospheric dynamics and composition, and evolution. Juno has already made many new discoveries about Jupiter. Scientists hope that information will help us measure Jupiter's mass and figure out whether or not the giant planet's core is solid. Let's resume what we learned about Jupiter and its internal structure. The composition of Jupiter is similar to that of the Sun, mostly hydrogen and helium. Deep in the atmosphere, pressure and temperature increase, compressing the hydrogen gas into a liquid. Scientists think that at depths, perhaps halfway to the planet's center, the pressure becomes so great that electrons are squeezed off the hydrogen atoms. Its fast rotation is thought to drive electrical currents in this region, generating the planet's powerful magnetic field. It is still unclear if deeper down Jupiter has a central core of solid material or if it may be a thick, super hot, and dense soup. That's all for this video. Thanks for watching, everyone. See you next time on the channel.